Hello and welcome to this course on MATLAB programming for numerical computations. We are in week 11 of this course. In this week, we are discussing partial differential equations. In the first two lectures of this week, we have discussed partial differential equations, introduced you to them, talked about classification as well as generically talked about methods for solving PDEs. Thereafter, in the third lecture, we talked about method of lines for solving parabolic PDEs, followed by method of lines for solving hyperbolic PDEs. In the previous lecture, we talked about finite difference approach for solving parabolic and hyperbolic PDEs. We will end this week by solving elliptic PDEs using finite difference approach. This is a bonus lecture. We are not going to actually solve any problem using MATLAB, but this is for the sake of completeness so that you understand the overall context of PDEs, especially because solution of elliptic PDEs using finite difference approach is sometimes covered in undergraduate courses. Okay. So, let us look at the elliptic PDE. Let us consider a slab, a rectangular slab where you have heat conduction taking place and the domain equation is dt equal to 0. The temperature at this location is TL. The temperature at this location, let us say, is TR. This loses heat to the surroundings and this loses heat to the surroundings. So, the boundary condition Okay. So, these are the kind of boundary conditions. Okay. So, what do we do in this particular type of a problem is we divide this entire domain into m grid points and into n grid points. Okay. So, this is going to be 1, 2, 3, okay. So, let us look at this particular okay. So, this d square t by dx square is going to be nothing but sorry. Okay, this should be 2 Ti comma j plus T I minus 1 comma j equal to 0. Okay. So, this is the domain equation for I going from 2 to n and for j going from 2 to m. Okay. What happens at j equal to 1? At j equal to 1, okay. So, these are the left and right boundary conditions. At the top and bottom boundary conditions, we are just going to use our Dirichlet boundary conditions. Okay. And now, we have n plus 1 multiplied by m plus 1 equations in n plus 1 multiplied by m plus 1 unknowns. We can solve them using any of the methods that we have learned so far, and we will be able to get the overall solution for the elliptic PDEs. Okay. So, that is our way of solving elliptic PDEs. So, with that I come to the end of this lecture. As I said, this lecture as well as the previous lecture, we are not going to cover this solution using MATLAB. I have added them as bonus lectures just in case you think you want to understand a little bit more for your use in your undergraduate courses. Okay. The primary lectures of interest in this particular week were lectures 11.3 and 11.4, where we discussed method of lines. Okay. That is what is going to be our workhorse for this particular course. Okay. If you want to solve elliptic PDEs, there are commercial softwares that are available that are meant for specific types of problems. As a result, solution to elliptic PDEs is not something that I am covering in a lot of detail. Okay. So, with that I come to the end of this lecture and indeed end of week 11. Okay. I hope you enjoyed watching this lecture, and I will see you in the next week. Thanks and bye.